Right, we are on part 2 of our ionic bonding recap. So let's get straight into it. We're going to be looking at some more difficult examples now. So let's look at this. We'll look at what happens when sodium and oxygen form an ionic compound. So we'll start by drawing out a sodium atom. There it is, we've got our 11 electrons, 1 on its outermost shell. Next, let's draw an oxygen atom. That there's got 8 electrons, so 6 on its outermost shell. And you remember that the metal atom there wants to lose electrons and the non-metal wants to gain. But you can see there's a bit of a problem. And the problem is this. If this wants to lose an electron, it loses 1. But oxygen wants 2 electrons to complete its outer shell. Okay, so that's the issue here. Sodium can give away 1 electron, but oxygen wants 2. So what do we need? Well, that oxygen, because it wants 2 electrons, what we need is 2 sodiums so that it gives it 2 electrons, okay? So we want this scenario here where we've got 2 sodium atoms, and so we've got 2 electrons here that can be given away on the outer shells to that oxygen. So like this, those are going to travel across and join onto the oxygen atom, and what will form is an oxide ion, like this over here. So we've got our sodiums, here they are, and you can see that outer electron is now gone. It's been transferred across to the oxygen atom. And so what we've got are sodium ions, and we've got 2 of them. Over here, we've got an oxide ion, and you can see you've got these 2 crosses, which are the 2 electrons that came from the sodium atoms. Remember, to show ions, we've got to put these brackets in, so I'll put these in now. Each sodium, because they lost 1 electron, is going to carry a 1+ charge. They're in group number 1, 1+ charge. And the oxide ion is going to carry a 2- charge. So what can you see? Well, you've got 2 pluses here and you've got a 2 minus. So these are now balanced, right? You've got positive ions, negative ions. What is going to happen? There's going to be electrostatic forces of attraction between the 2 of them, or ionic bonding. So there we go. Now, one more example. We're going to look at beryllium and fluorine. So what happens when they come together? Now, beryllium has 4 electrons, so 2 on its inner shell, 2 on its outer shell. We've got fluorine here as well. Fluorine has 9 electrons in total. So you can see that we've got 1, 2, 3, 4, 5, 6, 7 on its outermost shell. It's in group number 7, 7 on its outer shell. Now what wants to happen here? Well, beryllium, it wants to lose 2 electrons, right? But the fluorine only wants to gain 1. So again, we've got a bit of an issue here. What's the problem? Well, beryllium is going to give away its 2 electrons, but fluorine is only going to accept 1. So what do we need this time? Well, this time we need 2 of the fluorine atoms so that they can both accept 1 electron each from the beryllium. So we'll have this scenario here. So one of them electrons is transferred to one of the fluorine atoms, and one of these electrons is transferred to the other fluorine atom. And so we get these ions formed. Beryllium has now lost its 2 outermost electrons. So those are gone, goodbye. And now you've got each of these fluorines with 1 electron extra that they gained from that beryllium. And remember, to show that these are ions, we're going to put these brackets in. You've got a 2+ charge around the beryllium, and then a minus and a minus on each of those fluoride ions. We've now got positive ions, negative ions. They're balanced out nicely, so there's plenty of attraction between the 2, and those are electrostatic forces of attraction or ionic bonds. And there we go. So a few more complicated examples there, but I don't think that's too bad. So get practicing, find a few questions, have a go at them for some extra practice to make sure that you've nailed it.